All right, welcome to The Explainer. Today, we've got a really fascinating story for you. It's not about what psychology discovered, but about how it learned to discover anything in the first place. We're going to take a 100-year trip through the evolution of research methods, basically watching a brand new science figure out how to, well, be a science.
And this quote really sets the stage. It's from G. Stanley Hall, one of the founders of the Journal of Applied Psychology, way back in 1917. And you can just feel the optimism, right? He's saying, look, we know it's tough, we know it's confusing, but this isn't the darkness of night setting in, this is the twilight of dawn. It's the beginning of something huge. And that idea, that feeling of being on the cusp of discovery, that's really the heart of our story today.
See, the whole point of this new field was to solve real-world problems. We're talking industry, government, even the war effort. But to do that, they knew they couldn't just rely on, and I love this phrase they used, the opinions of educated men. No way. They needed tools, real, hard, objective, scientific tools. And this is the story of how those tools got built, fought over, sometimes even lost, and then found all over again.
Okay, so here's our game plan. We'll start in that twilight of dawn, see how they forged their very first tools, then watch how those tools were put to work. After that, we hit a period of major soul-searching about measurement itself, followed by a total explosion of new methods. And finally, we'll see where all of that leaves us today, looking toward what might be a brand new dawn.
All right, let's dive right in. We're starting at the beginning, the early 20th century. And the new field of applied psychology? It was completely, totally obsessed with one thing. How in the world do we actually measure people? Objectively, I mean. This whole era was about inventing the very first yardsticks for the human mind.
So if you look at what they were doing back then, it really boils down to four key things. First, this massive push for objectivity, getting away from just gut feelings. That led directly to the second thing, testing. I mean, the journal's very first article was about creating ability tests for police and firefighters. Super practical. Third, they were starting to build the first real tools for prediction. And finally, they had this deep fascination with the exceptional, the outliers, who they thought held all the secrets to human potential.
And you have to remember, this era was defined by absolute giants. You had Terman kicking things off with that first study. You had the legendary E.L. Thorndike, who identified the halo error, that bias where if someone's good at one thing, we just assume they're good at everything. That was him. It became the most cited paper of the whole period. And then there was Clark Hall, who gave the field this powerhouse tool called multiple regression. These guys weren't just asking questions, they were literally building the mathematical engine that would power psychology for the next century.
Now here's something that's kind of wild and shows how different their thinking was. A core belief back then was that the best way to learn about people was to study the outliers, the geniuses, and those who are struggling. They were doing these incredibly detailed case studies on gifted kids, top-tier marksmen. They even published papers with titles like The Moron as a War Problem. Yeah. The idea was to understand the average person, you first had to understand the extremes. It's a fascinating approach that, believe it or not, would basically disappear for the next 70 years.
Okay, so next up, the field moves into the 1920s and heads toward World War II. And as it grew, its focus got a lot broader. It wasn't just about measuring specific abilities anymore. The new ambition was to understand the whole person, especially how they fit into the world of work.
And you can really see the field starting to mature here. The research expanded way beyond just cognitive skills. They started trying to measure things like interests, values, personality, which led to famous tests like the MMPI. But, and this is a big but, these new tools brought new problems. They started realizing that just asking people questions about themselves, self-report, is actually really, really flawed. And that realization forced a huge shift in how they thought about doing science.
And this is maybe one of the most important shifts in the whole story. The field moved from what you could call a discovery model to a testing model. So instead of just gathering a bunch of data and saying, look what we found, they started saying, okay, we have a theory about how this works. Let's design an experiment specifically to see if that theory holds up. It sounds simple, but this was a massive leap forward. It's pretty much the foundation of how science is done today.
All right, fast forward to after World War II. The field is really hitting its stride now. It's becoming established. But with that maturity came a whole new set of problems. It was an era of setting rules, but also an era of starting to doubt those very rules. And it all kicked off with something that seems so small, almost trivial, a tiny cosmetic change in the journal itself.
So during this period, one specific statistical approach basically took over: null hypothesis significance testing. You've probably heard of the p-value, right? Well, the p-value became the ultimate gatekeeper. If your result was statistically significant, meaning it had a low p-value, it got published.
If not, it ended up in the file drawer. And one of the biggest side effects of this was that people stopped talking as much about effect size, how big or meaningful the finding actually was. The focus shifted from, is this important in the real world, to, is this statistically significant?
And then came that subtle change I mentioned. You ready for this? In 1954, the journal started printing the methods section in a smaller font. I mean, just let that sink in. The part of the paper that explains how the study was actually done was literally made smaller, less important. It was a symbolic message that the story you told was more important than the nitty-gritty details of your science.
Now, people noticed this stuff. By the time the journal hit its 50th anniversary in 1968, some pretty sharp critics within the field, like John Darley, were raising a red flag. He warned that psychology was in danger of getting amnesia, forgetting its own history and losing touch with the real world. He pointed out that the journal was becoming a place for professors to talk to other professors, not a place to help people actually doing the work.
But even in this era of doubt, two absolute game changers emerged. The first was meta-analysis. This was huge. It gave researchers a way to statistically combine the results from tons of different studies. It was a powerful blow against the idea that every finding was unique, and it proved that some principles really do apply across the board. The second was a technique called structural equation modeling, or SEM. This let researchers test these big, complex theories with lots of moving parts all in one go. These were seriously powerful tools for finding clarity in the noise. And then, the 1990s hit, and personal computers changed everything. Suddenly, researchers had access to sophisticated software that just blew the doors off what was possible. This kicked off what you could call a methodological explosion. There were so many new ways to analyze data, which was amazing, but also kind of overwhelming. Suddenly, you could build much more complex models. You weren't just looking at simple A causes B relationships anymore.
And you could look at more levels of analysis. Researchers could now study how individuals, teams, and whole organizations all influence each other at the same time.
This also meant using more data sources. The old way of just using one survey started to feel outdated. People began pulling in data from supervisors, from peers, from performance records.
But with all these new toys came more methodological debates. With so many options, the arguments about which one was the right one got way more intense.
And this led to a brand new kind of crisis. Think about it. With all these incredible new tools, how do you even choose the right one? And more importantly, who's actually been trained to use all of them? A study in 2008 pointed out something pretty scary. The methods were advancing at warp speed, but the way graduate students were being taught hadn't really changed since the 1960s. This massive, dangerous gap was opening up between what scientists could do and what they actually knew how to do.
But then, in 2007, another one of those small but deeply symbolic changes happened. After more than 50 years, the journal restored the methods section to its full-sized font. The scarlet letter was finally removed. It was a clear signal that the tide was turning, that the field was recognizing once again just how crucial it is to get the how of science right.
So all of this brings us right up to today. 100 years after G. Stanley Hall made that hopeful prediction, the field is kind of asking itself the very same question. Are we in the twilight of a new dawn, or is this the twilight of evening? The authors of this review argue that many of today's biggest challenges are, frankly, self-inflicted. Things like a reluctance to replicate old studies, to see if they still hold up. A tendency to look for evidence that confirms a pet theory, instead of trying to honestly test it. And yeah, a fascination with super complex, fancy analysis that can sometimes hide a weak study design. The bottom line is, the field is once again in danger of forgetting the incredibly hard-won lessons from its own history.
But just like G. Stanley Hall, they don't end on a pessimistic note. They're optimistic. They lay out 5 clear paths to get to that new dawn. 1. Make replication a top priority. 2. Bring back the study of exceptional people, those outliers. 3. Get much more rigorous about methods during the peer review process. 4. Put the focus back on solid design and good measurement, not just fancy statistics. And 5. Work on building theories that are more specific and actually testable.
So what does this all mean? After 100 years, maybe the biggest challenge for any science isn't just finding the answers. It's about getting better and better at asking the right questions in the right way. This whole journey shows us that science is always learning, not just about the world, but about itself. And the ultimate goal isn't just to pile up more facts. It's to relentlessly, constantly improve the very tools we use to find the truth. The real quest is to perfect the art of knowing.